Alright folks, hello. So in this section we're going to start concurrency theorem. So I just kind of want to start with a basic definition of concurrency. So in Euclid's fifth postulate with respect to parallel lines, and before this was the postulate that people tried to prove by using the first four postulates, and that didn't work out well. So now it's become its own postulate or axiom of which we can work with now. So again, this is kind of just to show the understanding of the language, and then how he tried to describe things back then compared to how we describe it now. And this is a general evolution of language that we will that actually happens in research and at the academic level, because it's like we try to describe something complicated, then it's like many years into the future we're gonna be able to describe it by a simple name. So if two lines intersect a third in such a way that the sum of the inner angles on one side is less than two right angles, so then the two lines inevitably must intersect each other on the side if extended far enough. So I'm kind of just going to work through that one. So I want to draw two lines. So if two lines intersect a third, in such a way that the sum of the two inner angles on one side is less than two right angles. So I need to draw two lines. Oh, sorry, not using the highlighter, using the pen. So I'm going to draw two lines, and then let's just draw two arbitrary lines. And then I'm going to do a third one. Then they intersect a third in such a way the sum of... Oh, okay. Now, okay, so it's better to actually draw it like this to really understand what's going on. So if I draw two lines like this, and then they intersect a third, and let's say I do like something like a traversal like that. So just to clarify, so this is line 1, this is line 2, and this is line 3. What's happening here is that they intersect a third line, is that the sum of the inner angles on one side, so it's less than two right angles. So it's the inner angles on one side can be either side, can be this side or this side. So what's actually happening here is that we can see that, well, it can't be this side because that inner angle is definitely more than a right angle. But if we look at the other side, we can see that the two inner angles here are both smaller than a right angle. So what's actually going to happen, as the postulate says, is that these lines are going to extend far enough that they will eventually meet at each other. So the interesting thing is that Euclid felt that he needed to describe parallel lines with the respect of the two lines have to be with respect to a third line. So that's just one way of thinking about it. Of course, now we call that concurrency, and this is the leading into what we call, or at least this section of videos where the idea of concurrency theorems is that we want to prove that a bunch of lines, or well, I guess for the most part a bunch of lines, but effectively a bunch of lines are going to meet at a certain point, but we still have to figure out how the constructions are done and the logic behind it. So that's what we'll be doing in these series of videos. So onto the sorry, that was awkward. Onto the next one.